Solution is over. So let us say finish. Now we need to go for the analysis with respect to the model. So let us come back over here and say solution. Again cross check for the analysis type. Let us come over here, say new analysis. And now we are going to solve this particular numerical with the natural frequency calculation model analysis. Let us say OK for the model. Once we are changing our analysis type, we must cross check for the analysis options. For this particular kind of numerical, we are having the two master DOFs associated with respect to Y1 and Y2, which are located at the mass location M1 and M2. So let us go for that one. Let us say reduced method. With respect to the number of modes of extraction, I am specifying 2. And again for the number of modes to expand as a 2. And let us say OK. Once we are showing OK, we are having one window by default. So let us say number of modes to print as 2. And just say OK again. So once we are setting for our analysis options, so let us go for master degrees of freedom. Let us say user selected. And now we need to define it. So let us say define. So we need to define our MDOF at two mass locations. So select those two mass locations. Just say OK. We are selecting those two mass locations at an UY degrees of freedom as a master DOF. And let us say OK. We can see these two purple color triangles added over here for the master degree of freedom MAST as our representation over here. So once we are defining our master degrees of freedom, let us come out of that one. Let us say define our load steps. In the load steps, we are not going to define any load step, but we need to control for our output. So let us say for output control. In the output control, we should say solution printout. So let us single click on that one. We are needing the printouts of the all basic quantities in relation with each and every substep. So highlight for every substep and let us say OK. Once we are controlling for the solution printout, let us go for results file. Single click on that one. Let us say every substep over here and just say OK. So once we are setting for our load step options with respect to the output control, let us come out of that one and let us say solve it. Let us say solve for the current load step. Close our status. We can see we are having the dimensionality as the 3D, which is having only 1 degree of freedom with analysis type as a model, and subtype or the extraction mode we are going to use over here as a reduced method. So let us close it and just say OK. We are going to get our solutions within a few seconds highlighted as solution is done. So let us close it. So once we are solving it for static, another time we are solving it for the natural frequency calculations. So let us come out of our solution and let us say finish without forgetting. So once we are solving it, now we need to again cross check for the harmonic impact loading. So it is harmonic response of this particular system. So let us again cross check for our solution. Say analysis type. Let us say new analysis. And now we are going to change it to the harmonic analysis. And let us say OK. Once we are changing our analysis type, now say define the loads. Let us say apply. Now let us say structural loading. Now we are having one additional load F0 magnitude, which is called as another excitation load or harmonic load. So we are having the magnitude of 50 Newton vertically downwards. So let us apply that one. Say force on the node. At the bottom node, let us say force in a y direction having a magnitude of minus 50 Newtons. And just say OK. We can see a red colored arrow representing the force of 50 Newton vertically downward. So let us come out of that one. Now we need to go for load step options. So select load step options. Let us come for the output control first. Let us cross check for the solution printout. Is it on every substeps or not? And let us say OK. Now we need to go for the results file. So let us come out over here and again cross check for every substep. And again say OK. Once we are cross checking it, let us come out of that one. Let us say frequency. So let us single click on time or frequency. It will highlight for frequency and substeps. Single click. We are having a frequency range which varies from 0.1 to the 1 Hz with an amplitude of 150 Newton. So here it is 0.1 to the variation up to 1 Hz. We are having the stepped input having a 50 number of steps. So let us say number of steps equal to 50 having a stepped boundary condition. And let us say okay once we are setting these. So once we are entering for all kind of an internal or external loadings, let us come out of your load step options and let us say solve. Solve this particular numerical for the current load step. Let us close our status command and just say okay. Say yes over here and our solution is done. So next stage we are going to see the results associated with this particular analysis in our next session.